What I want to show you today is one of my projects called Hydra. Hydra is a software plus hardware project. It's based on Raspberry Pi Pico, which is about $7 microcontroller. And the final assembly looks like this. Here is Raspberry Pi Pico connected via a USB cable to my laptop. And next to it is a debug probe. Of course, you don't need it all, and the final assembly looks like this. I mean, you only need Pico itself and of course the USB cable. The purpose of Hydra is to be able to control as many devices as you want, for instance, another laptop or all of your phones, using only your laptop keyboard and trackpad or a mouse. In addition to that, it's completely driverless. There is nothing to install on the laptop itself. I've got an old Android phone. Let me just turn it on. Let's say I would like to control it from my laptop. So what I can do is just go ahead to Bluetooth settings, and a new device called Hydra will pop up in the list of available devices. I'll press on the device. It will ask whether I want to pair. I'll press OK. And we have Hydra connected to my phone. Now, remember I said Hydra is completely driverless. There are two options to control it. The first one is using my desktop client, which I wrote for Windows initially. It sits in a tray area, and if I click it, it will display me all the devices I paired to. I've already previously connected it to my Surface Book 3 and my primary phone, and these are devices which are online at the moment. The third one is a new device which I just paired with, and it's my very old Android phone. So I'll just mark it as an old phone and click this icon to activate it. This is how you choose what to control. And then I will just press a hotkey, Ctrl-Alt, which essentially starts intercepting mouse and keyboard of the currently activated device. So when I move the mouse, it will actually move on the old phone. This is the mouse I'm moving, and that's what's happening on a phone screen. I can swipe it from the bottom, which will ask me for a PIN, like with the usual phone unlock screen. I can type the PIN from my laptop's keyboard. And then I can just go ahead and control the phone like I usually would. So let's say I'll open Edge, go into the URL area and type on my laptop, let's say test, which will appear on my phone as I type. The latency is very minimal. It's almost non-existent. The same way I can connect to my laptop as here, or actually any number of phones. I've also tried it on smart TVs like Fire TV. I've tried it on Samsung Smart TV. I've tried it on iPhone and my old laptops. It just works. So let me show you another way to control the devices. I will use something called MobaXTerm, which can connect to serial ports. MobaXTerm is the ultimate toolkit for remote connections, and I use it every day. However, you can use Putty or anything else. I've set up a serial port connection, which is connected to COM14. And I know this because COM14 was the only port when I plug in my board into the computer. The other two are something else I use for other purposes, and COM13 is the Pico debug probe. My desktop utility, by the way, knows which port is the board because it can identify it by the board signature. Press OK, connect to serial port. Of course, the access is denied because the utility is running in the background and occupying the port. So I'll shut it down. Try again. We've got the connection. By default, it's not doing anything, but if I type ? The board will return the list of commands it supports to the serial port. For instance, L is to list centrals. And you can see that I've got 3 centrals connected. In Bluetooth world, there are 2 roles, a central and a peripheral. A device, something like a mouse or a keyboard, is a peripheral. So my board pretends to be a peripheral. The device peripheral connects to is called a central. So your phone or a laptop will be a central. And I happen to know that this is my old phone I've just connected to because I activated it and it's marked with a star. I can switch between centrals using S command, unpair from all devices. There are some utility commands like start and stop advertising. In order to pair to the device, you need to put it in advertising mode. But the other thing I can do is something called an emulation. So if you don't want to use any software or just test the board, you can press E and it's going to enter the emulation mode. The point of emulation mode is simply to test that the board, working as a peripheral, can indeed pretend to be a keyboard and a mouse. T command simply types T. That's just to test that the keyboard is working. There is standard WASD keys, which simulate mouse movements. M is mouse latency test to test the Bluetooth chip performance, and X just exit emulation. So if I go ahead and try to play with WASD keys, let's see what happens. Okay, the phone is sleeping, but I'll go ahead and use the cursor keys. So I press W, see it wakes up, mouse cursor appears, and now I'm controlling the mouse. Can you see? I'm pressing right and the mouse moves there, left, it moves left, up and up, down is down. And there is of course a verbose login for operations happening at the moment, just for diagnostic purposes. I can also unlock the phone and I press T on the keyboard and it presses T. And this is how you test it. And just to show you the latency, when I press M, what's going to happen is the board will brute force sending Bluetooth commands to the active central to measure the performance. The performance test is complete, and as you can see from the readings, most of the time the latency is 0 milliseconds. But remember that we are trying to send hundreds of commands at once. Therefore, Bluetooth buffer sometimes backs up, and we have to wait for the Bluetooth chip to be free to send more commands again. Therefore, there is a random increase in latency, around 39-44 milliseconds. There's 88 sometimes. However, when you're just moving the mouse or typing on a keyboard as a human, the normal latency is 0 milliseconds. This project is also fully open source, and you can find it on the following address, alangood.hydra. There is a nice little picture I've done in paint.net and the short description. I'll also put the link in the description below. So the whole thing is written in C and C++. The Windows clients part is written in C++ only because I have a fever and it's higher latency and higher memory usage. Therefore, I just had to do it. I mean, look, if I open a task manager, you can see that the Hydra CPU usage is always 0% and it takes 1.7 megs of RAM. This is practically unheard of these days, and I wish more software would be this power and memory efficient. Also, the Windows client is highly optimized, so it doesn't consume any resources unless you ask it to. When it's in dormant state, like now, it will sleep until you press a hotkey, which is Ctrl-Alt. Temporarily install mouse and keyboard hook to be able to intercept the commands, of course. But as soon as you type Ctrl-Alt again, it will immediately uninstall the hook, re-register the hotkey, and go back to dormant state. And this is exactly what I want for my software. The Pico part is written in C and C++ as well, because I just couldn't get latency low enough with MicroPython. And in addition to that, I couldn't make MicroPython to expose mouse and keyboard as a Bluetooth peripheral. There is also so many customizations available in Pico C SDK that at this stage it would be almost impossible to write that in MicroPython. Well, let me know what you think about my project here in comments or in GitHub discussions, and hope you like it. And probably by the time you watch it, there will be some new functionality. See ya!